Okay, question 3 looks at a set of coplanar forces, right, where they specify the magnitudes. We're given some directions with degrees, and we're also given point or force, an unknown force acting at some angle. And the important thing is they tell us that all of these forces are in equilibrium. Okay? In other words, when we resolve the forces, the net effect is going to be 0. So what does it mean to resolve forces? Okay, when we are resolving forces, what it means is we're going to split our vectors up into two components, right? And these two components are going to be at perpendicular directions, okay? So if we consider a vector, so if we go back to thinking of vectors, if we have a vector acting in one direction and we have another vector acting in another direction, right? We can consider what the net effect of these two forces is, okay? And so the net effect of two vectors is we can join end to end. That would be what we call the resultant vector, okay? Now, when we are resolving forces, what we're doing is we're actually going from our resultant force and we are splitting it back up into two components that are perpendicular to each other. And we will do that for all the vectors, and we will use the same reference. And what we mean by that is we will specify what vertical and horizontal are. So usually vertical and horizontal are going to be straight up and down and perfectly horizontal. In other words, at 90 degrees to the vertical. Now, we don't always have to do things like that. We can change our perspective and we can consider vertical and horizontal to be at a different direction. So we could change the direction of what we want to consider vertical and horizontal, and we could resolve all the vectors in those two directions. Okay? Now it all depends on the question being asked and the information being given. If we have an unknown force, for instance like force P, it might be beneficial to resolve perpendicular to force P, because now we will only have force P in one of our unknowns. Okay. However, that would require us knowing all the other angles, and that could just become even more messy. So in this question, what we're going to do is we're going to consider our horizontal and vertical to be up and down, left and right. Okay. And so what we're going to do is split all of these four forces up into their two different components. So let's start with force P. Okay, so if we look at force P is acting off to the left at some angle, right? If we had to split that up into its two components, we would get some force going in this direction and some force going in that direction. Okay, so we have a horizontal component and a vertical component of those two forces. Okay. So how could we calculate those forces? Well, we know the magnitude of this force. In other words, the hypotenuse is P, right? Even though it's an unknown, we still know it. It has some magnitude. And if we consider the vertical component of that force, that is the angle opposite or the side opposite theta. And that is sine. So this force would be P sine theta. And just likewise, the force in the horizontal direction is the adjacent side, and so it would be P cos theta. And now we would just do the rest for all of the other forces. Now you don't have to actually do this, right? If you can see where the angles are, you can just write these in the equation, which we'll get to in a second. But for the sake of this question, I'm going to resolve all the forces. Okay, let's consider this 8 Newton's force. Okay, the 8 Newton's force can be resolved into the horizontal and the vertical component with the hypotenuse of 8. And so the opposite side, the vertical component, would be 8 sine 30 degrees. And the horizontal component is the adjacent side, so we would have 8 cos 30 degrees. So there we've split those two forces up. Okay, let's look at this 10 newtons force. So the 10 newtons force can be split up into the vertical and likewise, the horizontal and likewise the vertical. Its hypotenuse is 10. So if we consider the vertical component of that force, it's again the opposite side. So we'll have 10 sine, and the angle is 45 degrees. And the horizontal component is the adjacent side, and so it would be 10 cos 45 degrees. The final force, the 12 newtons force, we can see doesn't need to be split into two components. It only has a horizontal component, and so when we consider this force, it will only be acting, we will only be resolving it when we resolve horizontally. Okay. So what does it mean when the system is in equilibrium? What they're saying is that all the forces acting in the two perpendicular directions are equal to each other. So if in our example, we could say the upwards vertical forces are equal to the downwards vertical forces, and the forces acting to the right are equal to the forces acting to the left. In other words, they are in harmony, in equilibrium. Right? And that's what we're going to state now, and this is where we're going to get our two simultaneous equations to solve for P and theta. So, resolving horizontally. We can equate the forces on acting in opposite directions to each other, so we just need to be careful with which forces we're looking at. So we are looking at this point, let's first consider all the forces acting to the left. So the forces acting to the left are P cos theta, and we have 10 cos 45. Okay, those two forces are acting to the left, and if they're in equilibrium, they must be equal to the forces acting to the other side, so the forces acting to the right. So what are those forces? Well, we have 8 cos 30, and then we just have that 12 Newton force, which is only a horizontal force. Right, so from here we can rearrange things and we can isolate P cos theta by itself. And what we'll do is just take that 10 cos 45 to the other side. So at this point, make sure that your calculator is in degrees. So we'll go 8 cos 30 minus 10 cos 45 plus that 12. And we're going to get 11.8571, etc. Now, we need the exact value of this, so it's in your best interest to store this value in your calculator for later on. And you can possibly just, in pencil or something, mark the letter that you've stored it in. So I'm going to store this as A. So I have that value stored as A in my calculator for later. So vertically, we're going to do the same things. Okay, we're going to consider the forces acting vertically on the object. Now again, they're in equilibrium, which means the forces acting down must be equal to the forces acting up. So let's look at the forces acting up first. Okay, the forces acting up, I can see I have P sine theta. I also have that 8 sine 30. Those two are acting up, and now I can consider the forces acting down. And the only force acting in the opposite direction, in the vertical dimension, is this 10 sine 45. Just like before, I want to isolate my two unknowns. So we'll take 10 sine 45 minus 8 sine 30, and we're going to get 3.071, etc. Again, I'm not interested in the value. We're going to store this on our calculator. Okay, so I have both my values now stored in my calculator for later on. So having a look at this, we have p cos theta equal to 11.5, we have p sine theta equal to 3.071, and what we're going to do now is a little bit of equation manipulation, and we're going to solve first for the angle, and once we have the angle, then we can solve for the unknown, okay, because we can't solve them without each other because this is a simultaneous equation. Okay, so what we're going to do is we're going to take the vertical equation. We're going to say, well, p sine theta was equal to 3.071. Right? Again, we're just using that value, but we're going to use the actual value from our calculator. And we're going to divide this equation by the horizontal one. So we're going to get p cos theta equal to 11.857. And you can see that not only are the p's going to cancel out, but sine over cos is just tan theta is equal to 3.071 over 11.857. And now we can just take tan inverse and solve for theta. Now we can look at our diagram and we can see that theta is going to be acute. So that's very handy that we don't have to consider any of the other angles. So we'll take, on our calculator, what we're going to do is actually go tan inverse, and we're going to look at the values. 3.07, that was B, and obviously you're not writing this is just the thought process for your calculator, and 11, that was your A. So I would, on my calculator, say shift tan, right? I'm going to go alpha B divide by alpha A, and that's going to give me 14.52085, etc. So this is degrees, okay, because the angles we were given were in degrees. And when we are giving our answers for degrees, we need to round to the first decimal place, which is that 5 over there. And so we can round that to 14.5 degrees. Now again, we need the exact value of this for later on. So let's store this as value C on our calculators. Right, at this point we have two equations we can use to solve for P. Okay, we can use P cos theta equal to 11.8 or P sine theta equal to 3.071. So I'm going to use P sine theta is equal to 3.071. Again, not using 3.071, but the actual value stored in your calculator. Therefore, P must be equal to 3.071 over sine of 14.5. And again, not 14.5, but the actual value on your calculator. So I had 3.01 as alpha B. So I'm going to go alpha B divide by sine. And I've just stored my degrees in at C, so alpha C. And this is going to give me 12.24839, etc. And this is in newtons, so we're going to round to 3 significant figures. That's that figure there. So we'll get 12.2 newtons. So, just a quick overview again. In order to solve this, we had to split our forces into their two components. Again, we could choose which two perpendicular directions we wanted. You need to pick the one that looks the easiest. Okay. Sometimes it's better to resolve perpendicular to the unknown force. However, we weren't given enough information to do that, and so it was easier to just resolve in the horizontal and vertical plane. Understand that the forces were in equilibrium, so the forces acting in opposite directions are equal to each other, and then using some simple equation manipulation, solve for theta and then solve for p.